In this report, we present our recent progress about the Sachdev Ye Kitaev model, the SOK model, and its holographic duty. The SOK model is simply a quantum field theory model of a Marianas defined in zero-dimensional space-time, which only consists of purely random interactions. In the strong coupling limit, the system has conformal symmetry, and if we move away from the limit, the symmetry broken to SL2R. And the symmetry broken pattern is fully determined by the Straussian action here, which is strikingly the same in JT gravity. The JT gravity is a quantum gravity model by adding the scalar field phi to the ADC to space time. If we do the variation to the action with respect to the field phi, we find it reduced to the boundary term, and we need to cut off the boundary for the renormalization at the infinity with some line parameterized by the parameter u, and it turns out actions to be the Straussian of the real-time t and the parameter u. Now we choose the two boundaries of ADS2 spacetime, which is a trumpet geometry reminiscent of the wormhole configuration, and the quantum effect may make this slot exist or unexist. The recent proof found if we couple the scalar field onto boundaries by a technique called the double trace deformation, the wormhole becomes traversable, and the action here is exactly the same as two copies of SOK with some explicit coupling. Now it goes to the long-time dynamics of the SOK, which is quantum chaotic. The quantum chaotic defines the long-time universality because if a system is quantum chaotic, if it evolves over long time enough, the system becomes fully egoistic and all local details become vanished. The technique to identify whether a system is quantum chaotic or not is by computing its spectrum and thus its level fluctuation patterns and comparing it with the random matrix ensembles with exactly the same symmetry, which is the BGS conjecture. There are 10 kinds of universality classes for Hermitian systems, classified by 3 kinds of anti-unitary symmetries. And in our two-set SYK here, we can realize 6 out of 10 of them, however, all of them lacking the time reverse symmetries. For all cases, we consider that satisfy that Q larger than 2R. We find that sharp phase transition that can be seen from the phase block with the free energy and the time. It transists from this flat to this stand. The flat, we find the anomalous enhancement of the energy gap that beyond the portability result here, which can be interpreted as a wormhole tunneling effect. Also note, all this classification is pure symmetry analysis, the same as the Straussian action we mentioned before, so that this must have an impact for the holographic duty. Now we come to the topological index. The topology comes from when we generalize these real random couplings to complex, so the system becomes non-Hermitian with dispersive effects. And the system has the PG symmetry that allows a part of the spectrum become fully real, and at some parameters, some of these fully real modes will contribute to a topological index. In our setting, we choose real random couplings generalized to be fully imaginary. So our two-set non-Hermitian SOK here can be interpreted as a Lindebranding of a single-set SOK, which is a dispersive SOK. This is claimed to be due to the bracket wormholes in the near DS2 spacetime, and the topology comes to the non-zero trace of the chiral operator, which is interpreted as a chiral anomaly in lattice QCD. Here, we change the environment vastly, and we find the phase diagram will become widely called. And when we compute the Winding number of two diagrams, we find that the index is kept to the same, so that is robust. Also, this topological index defines a new kinds of non-Hermitian quantum chaotic classes with a solid non-Hermitian random matrix correspondence that has never been systematically investigated before. That's all. Thank you.